In this example, we're going to talk about adding momentum as vectors. Let's imagine that we have a football field. At least I think that's how the lines work, whatever, sports. So, we're going to have a 88 kilogram linebacker who is running toward the sideline at 9 meters per second. We're going to have him tackled by or rather tackle a 78 kilogram get tackled by a 78 kilogram running back going at 10 meters per second. You can tell that I know so much about football. And I want to know, once they hit each other, how fast will they be going and in what direction? And you might think, well, can't I just add these velocity vectors? But velocity is not the whole story. Their mass has something to do with it. So what we can do is add their momentum vectors. And you might think, well, what about kinetic energy? I just learned about that. I want to use that. That seems easier. Kinetic energy is not a vector. And this problem clearly involves directions. So this isn't going to work. I can't think about it that way. I have to think about something involving directions. Momentum, handily, is a vector. Momentum vector, mass times velocity vector. And we've already talked about how to add vectors. So once we've got this in a vector situation, this is just adding vectors together. So let's call the 88 kilogram guy 1 and the 78 kilogram guy 2. So momentum of 1 is 88 kilograms times 9 meters per second, which I get is 792 kilogram meters per second. If we want to talk about it as a vector, he's heading that way. 2 is 78 kilograms times 10 meters per second, which is 780 kilogram meters per second. And he's heading that way in my picture. Well, now I just have two vectors. I have one vector like this, and one vector like this. So if I want to add them, I take vector 1, I take vector 2, and then draw a line from tip to tip, which I made a video early on about in the semester. Well, this now looks like a right triangle. So remember, this was 1, this was 2. And if I want to find the hypotenuse of a right triangle, it's just the Pythagorean theorem. So that means my resultant vector of momentum will be rho 1, sum of the squares, square rooted. And if I do that, if I plug in these numbers here, I get that my resultant momentum is 1,112 kilogram meters per second. And then I can find the overall velocity, and I'm just using r for resultant, so the result of when they collide. We rho r over their masses, because now they're moving together, so they have combined mass. That's 1,112 kilogram meters per second, and 166 kilograms if I add that together. So I find their velocity is 6.7 meters per second. But what if I want to know the direction? Well, in that case, I've got to figure out where to measure from. So let's say here, theta. In this case, it's going to be inverse tangent rho 2 over rho 1, opposite over adjacent. And when I do that, I get theta is about 45 degrees. And so, to slow down, I just plugged in 780, 792, and did the inverse tangent. That's how I got 45 degrees.